When we prompt a text-to-image model with something like, in the style of Impressionism, we usually think of it as applying a visual filter. We expect changes in brushstrokes, color palettes, and texture. But what if those style keywords are actually carrying something much heavier? What if they're embedding historical social hierarchies, specifically around gender, straight into the generated image? That's exactly what a recent study from researchers at the University of Amsterdam, ULB, HPI, and Osaka University investigated. They found that artistic styles aren't just aesthetic choices. They're socio-historical constructs that encode gendered visual patterns, and modern generative models don't just copy them. They amplify them. To test this, the team introduced STYLEGENDER, a new dataset designed specifically to measure how gender representation interacts with artistic style across both historical paintings and AI-generated images. It contains roughly 74,000 images, spanning 19 distinct art historical styles. The dataset is built in 3 parts. First, they curated about 18,000 historical artworks from WikiArt, filtering for male and female subjects, and manually verifying gender labels. Second, they generated 19,000 images using 2 state-of-the-art text-to-image models, Stable Diffusion 3.5 Medium and Flux 1 Dev. They used highly controlled prompts that only varied gender, viewpoint, pose, and style keyword. Third, and this is the clever part, they created a semantically aligned set. They ran the historical images through a vision language model to generate detailed captions, cleaned them to remove style references, truncated them to fit the text encoder, and then regenerated them with the style keyword appended. This gives them a direct, apples-to-apples comparison between historical art and AI generations of the exact same scene. But how do you actually measure a hidden gender bias in a style? You can't just ask a human to guess. The researchers built 2 novel metrics to quantify what they call set gender artifacts. These are visual cues that are strongly correlated with gender, learnable by a classifier, and have an interpretable human meaning. The first metric is PIXELSGA. This measures gender signals at the raw pixel level. They take every image in the set and systematically downsample it to resolutions ranging from 14 by 14 pixels all the way down to a single 1 by 1 pixel. At these low resolutions, high-level semantic details vanish. You're left with only coarse structural information and global color distributions. They then run these downsampled images through 3 different color encodings: standard RGB, grayscale, and binary black and white. For each resolution and encoding, they measure the balanced accuracy of a gender classifier. PIXELSGA is essentially the average of the highest balanced accuracy scores across these degraded representations. If a model can still tell male from female after you've crushed the image into a few pixels and stripped away fine detail, that's a strong pixel-level gender artifact. The second metric is MASKSGA, and this one isolates gender cues in compositional structure and contextual background. Here, they use a transformer-based object detector to draw bounding boxes around every human figure in the image. They create 2 manipulated versions of each image. In the first, they mask out only the human subjects, leaving the background and scene context intact. If a classifier can still predict gender from this version, it means the bias is baked into the environment, the props, or the lighting. In the second version, they mask out both the subjects and the background, leaving only the spatial layout, scale, and placement of the figures within the frame. MASKSGA is the average balanced accuracy across these 2 occluded conditions. It tells you how much gender information is encoded purely in composition and context. For the classifier itself, they use a k-nearest neighbors approach with k equals 5, operating on clip embeddings extracted from a conv-ni-xt backbone. They deliberately avoid training a model from scratch because the dataset has uneven style representation, which would cause severe overfitting on smaller style classes. Instead, they rely on the pre-trained semantic space of clip, subsampling the majority class per image to handle class imbalance, and they rigorously validate the setup with a monotonicity check. Since downsampling should theoretically degrade classifier performance, they confirm that accuracy drops consistently as resolution decreases, ensuring the metrics are actually measuring signal and not noise. So what did they find? First, historical art isn't neutral. Every single style in the dataset shows measurable gender artifacts above random chance, with symbolism being the closest to baseline. Neoclassicism and Art Nouveau score the highest on both metrics. When you look at neoclassical paintings, you see systematic differences in setting, color palette, and pose between male and female subjects. Art Nouveau leans heavily into stylized, often objectified female representation. These aren't random quirks. They're encoded visual conventions that the models learn. When they test the text-to-image models, the pattern holds, but with a critical twist. Simply changing the style keyword in the prompt systematically modulates gender separability. Stable Diffusion and Flux both inherit these artifacts, but they distribute them differently across styles. For SD, Rococo, Romanticism, and Baroque show the strongest amplification. For Flux, it's Impressionism, Post-Impressionism, and Contemporary Realism. But the real headline comes from the cross-domain comparison. When you take a historical painting and regenerate it with a style prompt, both models consistently push PIXELSGA scores higher than the original artwork. The amplification is most pronounced in Flux, and it's particularly strong in styles like Rococo. The models aren't just copying historical gender norms. They're exaggerating them, especially at the pixel level. MASKSGA shows some variation, with certain abstract or highly stylized movements like cubism or surrealism actually showing lower artifact scores in the generated versions, likely because the models struggle to maintain strict compositional fidelity when style conditioning dominates the latent space. This has serious implications for how we think about style in AI research. For years, style transfer and T-Y conditioning have been treated as separable from content. We assume you can strip away semantics and just apply an aesthetic layer. But this research proves that style and content are deeply entangled. Style keywords act as implicit prompts for historical social structures. When you condition a generative model on Neoclassicism or Art Nouveau, you're not just asking for a specific brushstroke technique. You're invoking a dataset of historical paintings that were created within rigid gender hierarchies, and the model learns to reproduce those hierarchies as visual features. Even worse, diffusion models tend to amplify them, likely because the training data contains statistical overrepresentations of these tropes, and the generation process reinforces them through iterative denoising. The researchers are transparent about the limitations. The dataset is heavily Western biased, with only one non-Western style represented. Abstract art introduces ambiguity in gender labeling, and the vision language captioning pipeline can occasionally hallucinate or misidentify subjects in complex compositions. The clip text encoder's token limit also forces truncation, which can drop subtle visual details. And yes, relying on binary gender labels inherently risks reinforcing categorical stereotypes, which is why the dataset is released under a non-commercial license to encourage responsible academic use. But despite these constraints, STYLEGENDER provides a rigorous, quantifiable framework for studying how aesthetic conditioning carries social bias. It moves the conversation beyond vague claims about AI stereotypes and gives us concrete metrics to audit how style conditioning affects representation. As text-to-image models become standard tools for creative and commercial workflows, understanding that style is never socially neutral is crucial. It means that prompt engineering isn't just about aesthetics. It's about curating historical context, and generative models are actively participating in that curation. If we want to build systems that don't just replicate historical inequalities, we need to treat style not as a filter, but as a dataset. And this research gives us the tools to finally measure what's inside it. If you're working with diffusion models, style transfer, or bias evaluation, I highly recommend checking out the full paper and the open dataset. The code, metrics, and generation pipelines are all available, and it's a fantastic resource for anyone looking to audit how aesthetic conditioning shapes model behavior. Let me know in the comments how you've seen style prompts affect